Today we're going to look at 8.3, graphing general rational functions. This is a little bit more involved than what we were doing the last 2 days, but it's really similar. You can see an example of what we're going to graph above with the little ants sliding around. Alright, so our goal is to graph general rational functions. And then I have another picture of a general rational function below. Sometimes I don't have any vertical asymptotes, and that's an example of not having a vertical asymptote. Alright, so don't write this down, but this is what it looks like in true mathematical form. This is a general rational function where it has a degree of m and n. What's most important is that you recognize that m or n has to be greater than 1, and that's what makes it a general rational function instead of one of the simple rational functions. Alright, so this is the page that you're going to want to copy down, or you can print out the picture that's on the online, and you can just cut it out and paste it in your book if you'd rather do that. But either way, you want to have this in your notes. So either pause and write it down, or pause and print it out and tape it into your notebook. But no matter what, make sure that you have this in your notebook. Alright, so if we look at this example where it says graph y equals 4 over x squared plus 1, which one of these is it? Is it the first example? Is it example 2? So the first example here looks like this, or is it example 2, or is it like this third one? So the reason is anytime you have an exponent that's greater than 1, where the degree is greater than 1, then that's when you use this third step. All right, and that's how we knew that we were supposed to use this one. If it wouldn't have had the squared, then it would have been like this first one. But it does have the squared. Alright, so I've kind of worked this out ahead of time. So let's go ahead and go through it. So first off, step 1 is to find the x-intercepts. So in order to do the x-intercepts, you basically set the numerator equal to 0. And then you solve for x. Well, in this case, our numerator, 4, does not have an x, so that doesn't do us any good. So that means that there are no x-intercepts because we don't have an x to solve for in the numerator. The vertical asymptotes is still where you set the denominator equal to 0, just like it was in the other two cases. So if we take the denominator and I set it equal to 0, so I have x squared plus 1 equals 0, and I solve, so minus 1, take the square root. The square root of negative 1 is plus or minus I. So that means that there's no vertical asymptotes because this is imaginary. You can only have vertical asymptotes if you get a real number here, and I is not a real number. So we don't have any vertical asymptotes. So now the next step is the horizontal asymptotes. So on the horizontal asymptotes, we have to look at m and n. M is in the numerator. M is the exponent up here, so this is m, which is 0, and this is n. So we have m equals 0, and we have n equals 2. And then we just see which one it is. So is m less than n? Is m equal to n? Is m greater than n? So since m is 0 and n is 2, that means that m is less than n. 0 is less than 2. So we're going to pick the first one, which means that we have a horizontal asymptote at y equals 0. So once we do that, we're going to make a t-chart. All right, so usually what we do is we use vertical asymptotes, and we pick 2 to the left and 2 to the right. But we don't have any vertical asymptotes. So when that happens, when you make your t-chart, you use negative 2, negative 1, 0, 1, and 2. So we have x, y, and then we just pick negative 2, negative 1, 0, 1, and 2. All right, and then we don't have to check the end behavior because if you look here, we only have to check the end behavior if m is greater than n. M is less than n, so we don't have to worry about that. So if we look at this, here's all the little x's that we wrote down before, the negative 2, negative 1, 0, 1, and 2. And then we just take each of these x's and we plug it in for here. So 4 divided by negative 2 squared plus 1 is 4/5. 4 divided by negative 1 squared plus 1 is 2, and so on and so forth. You just keep plugging those in. So now we're ready to graph. So we're going to graph negative 2.8. We're going to graph negative 1, 2, 0, 4, 1, 2, and 2.8. So it looks like this. It kind of goes along the asymptote, and then it goes up, and then it comes back down, and then it goes along the asymptote. So on this one, the domain, x can be whatever it wants. And it doesn't have any restrictions at all because there's no vertical asymptote. So it can be any real number. The range is a little bit trickier because if you notice, the highest number that the range can be is 4. So y has to be less than or equal to 4. But there's also an asymptote at 0. And if you notice, there's no graph underneath 0. So that means that y has to be greater than 0. Can't be equal to 0 because there's an asymptote at 0, but it can be greater. So it can be any number it wants to be between 0 and 4, but it'll never be more than 4, and it'll never be less than 0. Okay, so let's look at another one. And you don't need to write this down. You can just listen to what I'm talking about here as long as you have example 1 down. That's most important, and if you want to write this down, that would be outstanding. So first off, the x-intercept. So if you remember how we found the x-intercepts, we set the numerator equal to 0. So I'm going to take the numerator and set it equal to 0. So that's going to be x squared equals 0. Solve for x, and x is equal to plus or minus 0, which is just 0. So we have an x-intercept at 0, which means that the graph touches the x-axis at 0. A vertical asymptote is where you set the denominator equal to 0. So we're going to set the denominator equal to 0. If I can ever write. Set the denominator equal to 0. Jeez, oh. I'm not going to be able to write it apparently. Denominator equal to 0. Definitely a good update here. Okay, so we set the denominator equal to 0. So we take the denominator, which is x squared minus 1, and we set it equal to 0. So either you can plus 1 and then take the square root and get plus or minus 1, or you can factor the difference of two squares and get plus or minus 1. So we have two vertical asymptotes, one at positive 1 and one at negative 1. So now we go to the horizontal asymptotes. So we look at m, which is up here on top, and we look at n, which is on the bottom. So it's m is the degree of the numerator, n is the degree of the denominator. So m is equal to 2, and n is equal to 2. So we have 2 equals 2. So if that's the case, then it's equal to the leading coefficient of the top divided by the leading coefficient of the bottom. So this is where we got the 1 from. This is a to the mth. And this is where we got, a sub m. And this is where we got the 1 on the bottom. This is b sub m. So it's the coefficient of the top, and then this is the coefficient of the bottom. And technically, it's the leading coefficient. And that's where we get the 1 over 1. And that's where the vertical asymptote is. That's where the horizontal asymptote is at y equals 1. So then we skip down to make a t-chart. So this time we're going to pick 2 to the left, and we're going to pick 2 in between, and we're going to pick 2 to the right. And we don't have to worry about this last step because we didn't pick the m is greater than n1. We had m equals n. So when I look at the graph, I picked, let's figure out how we got these numbers. First off, I graphed the line at -1, so vertical line at -1. So here's this one at -1, and then we graph the vertical line at +1, and then we graph the horizontal line at y equals 1. So that's where all those lines came from that work that we did. And then we know that we have an x-intercept at 0. Right, so we know we have a point there because that was what we got from our very first step that we did. So that's what I did first. I always do the x-intercepts first. And then our rule is to pick 2 to the left and 2 to the right, and 2 in between. So 2 to the left of this left one would be -2 and -3. So here's -2, here's -3. That's why I picked those two numbers. And then in between, I can't pick anything. I can't pick 1 or -1 because those are asymptotes. So I had to pick a half, -1/2, and +1/2. And then I have to pick 2 to the right. So this would be 2 and 3, right? And that's where all those numbers came from. So then we just plug them into the function. So -2 squared is 4. 4 divided by 4 minus 1 would be 4/3. And then so on and so forth, plugging all those numbers in. And you could just use your calculator to plug them in or do it by hand. So then we go ahead and plot. So we have -2, and then 4/3 is 1 1/3. So that's going to be up here. And then we have -3 9/8 is 1 1/9. So that's a little bit closer. Sorry, 1 1/8. So it looks like this, kind of coming around and going up. Restricted by the asymptote, kind of came a little bit closer. And then we plot -1/2, -1/3. And then we plot +1/2, -1/3. So it looks like this, little parabola in the middle. And then we plot 2, 1 1/3. And we plot 3 and 9/8, and it looks like this. And that's our graph. So the domain is kind of crazy. X can be whatever it wants. So X can be an element of all reals, except X cannot be plus or minus 1, because those are the two vertical asymptotes. And for the range, Y can be an element of all reals, except Y cannot be 1. So very similar to what we were doing before, right? And then we'll do the last one tomorrow, so I can show you how to do the end behavior. I kind of like just to make sure that we're understanding before we go on. So make sure that you have that first example down. Make sure that you have the notes from the beginning that were down, the step-by-step process, and then we'll go from there. If you have the notes down in your notes, all it is just following this step-by-step process to graph these. If you don't have the notes, you've really put yourself at a disadvantage, so make sure that you have those.